Hey, Jam. We've got some fun questions from listeners today. We're going to talk about why people hiccup when they eat carrots. We're going to talk about some cool applications of poinsettias in food packaging. We're going to talk about benzene, catalyst, and a potentially scammy water cup.
Oh, interesting. Okay.
You ready to get into it?
Let's do it.
Let's do it. Hey, I'm Melissa.
I'm Jam.
And I'm a chemist.
And I'm not.
And welcome to Chemistry for Your Life.
The podcast helps you understand the chemistry of your everyday life.
Bonus edition.
Bonus. Ask a chemist.
Yeah.
Are we ready to ask a chemist?
I mean, I'm the chemist, so I won't be doing the asking.
And I'm not a chemist, so I will be. Wow, I've never heard of this. When you said that in the teaser, I was like, what the heck? So this is from Claire, one of our H-bonders on our super cool chem community on Patreon, patreon.com/chemforyourlife. Why do me and my uncle get hiccups when we eat carrots?
Okay, so I normally have a rule against Googling for bonus episodes, but I did Google for this or researching in any way. And lots of people, there was like, it's a thing. There was like little, not research articles, but like little think pieces and TikTok videos, and like people experience this.
That's so strange.
I know, but it's Claire and her uncle. And so first I went and researched to make sure like what this is from actual research articles, peer-reviewed journal articles, like what are hiccups, and they are spasms of the diaphragm. And they, when this muscle spazzes, then the epiglottis, I guess, closes rapidly, and that makes it to where you're not getting a lot of breath in, and it generates that sound and like the sense of discomfort. And so, it can be caused by a lot of things that impact the muscles, but it is believed to be induced by a rapid stomach distension. Like if your stomach gets really like big fast, is what distension is. And that irritates the stomach. And so that could be from overeating, from eating too fast, from having spicy foods, from drinking too much carbonated water, things like that. And so when I read that, my first thought was, and there's not a lot of evidence on like why this happens or exactly the mechanism, but I read that and thought there must be something either genetically about the way that Claire and her uncle eat the carrots, or the way that their, bodies are, that when they eat the carrots, they ingest a lot of air with it, or they might have some kind of reaction, like like allergic reaction or response to some of the molecules in the carrot that has this effect. But then I kept reading because I was like, but why do people hiccup?
Right.
And there was a very convincing article published in a peer-reviewed journal where it was like, oh, people think it's like to get, if you have like too much food, like a food in one area, like to help it out or whatever, but the hiccuping motion would bring the food up. And that's not good. And we have like a vomit mechanism for that. So that would, be more effective. And so we like went through all these like suggestions of why we have hiccups and why none of them are probably right. And then got to the last one, which is he suggested that it is an evolved burp reflex to get air out of the stomach, which with the epiglottis closing makes sense. And it happens more in infants than adults. And since infants like have the like it's pretty complicated when you're like breastfeeding or nursing, or like you're trying to breathe and you're also sucking, and all these things happen that then you can get a lot of air in also. And hiccuping is like an evolved mechanism to get a lot of air out.
Oh, wow.
And that would make sense why a distended stomach, or like a lot of air, a rapidly expanding stomach would trigger it, because it's like, oh, our belly's not supposed to get this big this fast. So boom, get it out.
Dang.
So that was really exciting.
That's crazy. I have not noticed any trends in my own hiccuping, like it's related to certain foods or something like that. This is maybe the first I've ever heard of someone having that about any certain food, period, let alone carrots. But I've had a few times where I've gotten hiccups that just have stuck with me for a while, and I'm like, what is going on? Like, this is torture. Like,
Yeah.
I hate it, and I've not figured out. It's not happened often enough for me to figure out some sort of.
Well,
yeah.
Chronic and prolonged hiccups can actually be like signs of underlying diseases, and there are lots of things that trigger it, not just food, but it's also like it could be from nerves, or there's like GERD, acid reflux things can trigger it. There's all kinds of things that can trigger it.
Man,
mine is more like if I eat a lot of food without drinking enough. Sometimes it happens. But yeah, they are painful, and I hate them, and they feel embarrassing, and I get mad.
Yeah, I don't get embarrassed, but it's a little painful, uncomfortable, and also if like I'm talking to people, while you're eating or something like that, and then like, you keep interrupting yourself to hiccup. It's like, golly, stop, Just so, yeah.
Yeah.
Mm.
I'm with you.
Man, okay. Are you ready for this next one?
Yes.
Why was the benzene in aerosolized dry shampoo so bad? This is from Ashley B through our website.
Okay, so benzene is a carcinogen, and that means that lots of things have benzene rings in them, but they have other groups of atoms attached to it, and that makes them not a carcinogen. But benzene by itself just happens to be something that encourages cells to grow rapidly in a bad way, which is what basically cancer is. And so benzene by itself is bad. And if you want more information on that, you can go to episode 102, which is what is benzene and why is it in my sunscreen? And get a little bit more information on how it might have ended up there and what is not good about it. So yeah.
That's crazy. That's 101 episodes ago.
Yeah.
Wow.
Yeah, because we're past our 200th episode now, which I meant to do something to celebrate and forgot.
We can celebrate whenever we want.
That's true. Like, hey, 217 episodes. Let's make a cake or something.
Oh yeah. And wait, was that one idea you were thinking about for 200?
Oh, I think hot ones. Maybe.
Might happen.
It happens.
Speaking of hiccups.
And that would give us hiccups. Yeah. Mm-hmm.
Do you want to read this next one or want me to?
You can.
So this is from, I was noticing at the beginning a comment, this is from Charles P through our website. I really enjoy your guys' show. I have a question about chemistry that may serve as an episode topic. I understand what a catalyst does. However, what are the factors that determine if a molecule or substance will be a catalyst in a reaction? For instance, if a substance is a catalyst in one reaction, will it be in another? Why or why not?
This is a really good question. So there's different types of catalysts, and there are some, like enzymes are catalysts, and so they have like specific binding sites where something has to fit right in to work. But in chemistry, we say synthetic organic chemistry or synthetic inorganic chemistry, you're essentially synthesizing molecules. And sometimes you can add material like an acid or a metal or something as a catalyst. And the key features of that kind of catalyst is that it helps the reaction go faster. And it's regenerated. It doesn't technically just help the reaction go faster. It lowers the activation energy, I think. Is that true just for enzymes or all catalysts? Now I can't remember. But essentially, it makes the reaction go better. And it's regenerated in the end. And I would say the thing that determines if it's a catalyst in a reaction is about the reaction mechanism. So when I say reaction mechanism, that is how do the electrons physically move to make and break bonds? So bonds are typically made up of two electrons, and pairs of electrons will move together to make new bonds or to break apart and, make a lone pair or something like that. And so if, for example, I add a little bit of acid to something, that acid might the protons in the acid can add to one molecule, or if you add a little bit of base, the base might take a proton away from something else. Basically, it'll do like a little mini reaction or like a pre-reaction that makes the other two things that you want to be attracted to one another more or less attracted to each other. And so it really all depends on how are the electrons moving, and can I use something to make the electrons move the way I want them to, faster or easier or in a more specific way. So that's the best way I can answer that question.
Huh. Interesting.
Yeah, I don't know. Is it interesting?
I mean, it's a kind of question that I think part of what's interesting is I don't know if I ever would have thought of that.
Yeah.
You know, like we've talked about catalysts and enzymes and
enzymes
stuff.
are easier to think about, I think.
So catalyst is like a role almost.
Yeah, it's like it's just a helper, you know, and it has to be regenerated. So we'll put like a catalytic amount of acid is almost like a trace amount of acid, or like sometimes metal is a catalyst. So the metal doesn't get used up. It's not part of the reaction. Like in one reaction, hydrogenation, which we've talked about before. I don't remember on the episode, but we talked about
margarine.
Yeah, margarine, trans fats. There's a metal catalyst that sort of like the hydrogen atoms line up on the metal, and it makes it like more orderly and easier for the reaction to go. So there's just all types of things that can happen.
Interesting.
Yeah.
This next one, okay. I have not heard of this. This is what you mentioned a second ago from both Mason's grandmother and y'all's roommate Miriam, our friend Miriam. Thoughts on the hydrogen-rich water cup?
Okay. So this is a little water bottle that has a little thing on the bottom that I think it maybe claims to generate hydrogen gas. And then your hydrogen gas will be in your water, and that'll improve things about your water. So both of them asked me what I think about it, and I did very briefly look up some things, but my first big thought is I don't see where the hydrogen is coming from unless this thing is breaking apart molecules of water and isolating hydrogen gas out of them, which is possible but would take quite a bit of energy, and it's just like a little water cup, you know? But also, I believe that hydrogen gas has pretty low solubility in water because it's nonpolar, and water is very polar. And so I think it would be hard to, if you are generating the hydrogen gas, to get it to stay in the water. It's also, hydrogen gas is really flammable. So I think if they really were generating a large enough amount of hydrogen gas to make a difference, that could be a liability, because if it like stockpiled, then it could catch on fire, which is what happened to the Hindenburg, right? Isn't the Hindenburg the blimp that was?
Yes,
yeah.
I believe so.
So that's just my very initial thoughts. Water is already really good for you. And so I think you can just drink plain water.
Yeah.
And if you're doing that, that's good enough.
Have they made any claim at all anywhere about like, why you want more hydrogen? Like, I don't understand.
Oh, yes. There's all kinds of claims. Let me see if I can look it up.
I just don't understand why you'd want more hydrogen. I'm like, isn't there already a lot of hydrogen in this? Like,
hydrogen-rich water
H2O
cup.
means there's 2 atoms of hydrogen per 1 of oxygen, right?
Rechargeable portable glass hydrogen water generator bottle for $100.
Oh, it's only $100. Oh, okay.
So it says that there's a proton exchange membrane making molecular hydrogen. This would be a fun series, I think, where I just read insane claims.
Yeah, I'd love that.
Produces best antioxidant for you. So first of all, antioxidants are typically long chains of molecules with alternating double bonds like you find in fruits and berries.
Right.
So that doesn't make sense, but it says hydrogen generator produces best antioxidant for you. Molecular hydrogen is a novel antioxidant. I don't I haven't read about that.
Interesting. So I guess it's molecular hydrogen. Oh.
I know. What does molecular hydrogen even mean? Like, all hydrogen is a molecule, and it's typically exists in a diatomic form of H2 gas, or it's in other things. And guess what? The molecule of hydrogen is already in water, 2 of them.
Right.
So I just don't know. It says hydrogen-rich water helps improve mobility and muscle function, which reduces body fatigue.
What if with like as much sincerity and earnest as you could muster, you called this company and you were like, guys, I have amazing news for you. I was just kind of looking into y'all's product, all that kind of stuff. And guess what? I was thinking about like, oh yes, this is awesome. There's hydrogen. And then I wanted to let y'all know that there is hydrogen, lots of it, in water.
Yeah.
And like said something kind of like you don't have to worry anymore. Like there's actually, I found a lot of it for y'all.
It's actually in there.
I
was researching
and it's like not nearly as flammable when it's in the water form. So
something I do like to do sometimes is go to Reddit Chemist r/chemistry and ask them or see what they say about it, because it is a community of people who say they're chemists.
Mm-hmm.
But they usually have very similar takes that I do, and it really boosts my confidence.
Nice.
There is one of these hydrogen water bottle. Could anyone touch on this new idea of hydrogen water bottles? From what I read, they have generators at the bottom, and they use electrolysis to infuse more hydrogen into the water. However, with the half decent knowledge of chemistry I have, I think the energy is too little for electrolysis. And the main thing is I ran a friend's bottle for a long time and saw no decrease in water level. If electrolysis is really occurring, the water level should go down, which would make sense if you're using the water to make.
Oh.
Yeah. In addition, when you turn theirs on, a cloudy mist comes through the bottom at the water and the water goes cloudy. This makes me wonder what that actually is. So somebody said, it's a scam. It's always a scam. No, somebody else talked about the low solubility of H2 gas in water, 1.6 parts per million at room temperature and pressure. So, that's interesting.
Mm-hmm.
But this is under 1 atmospheric pressure. Despite the low solubility of H2 gas in water, which can be only up to 1.6 parts per million under 1 atmospheric pressure, hydrogen-rich water has been shown to be effective for ameliorating various diseases caused by oxidative stress in animal and clinical studies. So that's interesting. Hydrogen could be good for you, ? In your water, but there is no evidence that this actually improves this at all. So, and I do think that is the biggest thing is hydrogen is not soluble in water. So if this thing is able to actually generate hydrogen, it would be very hard to put the hydrogen in the water.
Mm-hmm.
And then does it have any positive health benefits? And so all those things together is like too many ifs for me.
Mm-hmm.
And there are lots of the mumbo jumbo. Molecular hydrogen and novel antioxidant, which there is a maybe peer-reviewed journal article that talks about it acting as an antioxidant, but I don't know who published this or who paid for it, et cetera, et cetera. So I'd have to look into it more, but off the bat, I would say that $100 on a water bottle that supposedly is putting hydrogen in it through electrolysis is probably not real. And that's that.
That's that.
I do think we should do a series of me reading ridiculous products and talking about them.
I'm down for that. Like, I don't have any of the credentials to really give any judgment on them in a professional sense, but I would love to judge the products from a judgy, opinionated person sense.
Yeah.
Is that cool?
I love judgy, opinionated people.
I've got comments I can make. I've got,
It reminds me of the alkaline water, which is like the only potential effect I could think that alkaline water would have is if you have acid reflux. It might cancel some of that out. But otherwise, the buffers in our body are going to neutralize anything that's outside of a typical range, and your body's going to function exactly the way it's supposed to.
Yeah.
So not really worth it to spend more money on it.
Yeah. Agreed. Okay. This is, I remember seeing this comment come through from Angel G on YouTube about 800 C. What's the C? Celsius. And 200 atmospheres. Is that what that is? Is what you need for water to turn supercritical.
Okay, so that was on our episode about supercritical water.
Oh, yeah.
And I found on just...
Remember one of those comments that was like...
that one got lots of comments.
It was like, that's called gas or something like that.
Yes, yeah.
Like,
yeah.
It was like, no, it's not. It's not that. It's different.
Yes.
Listen to the... It was just funny.
There was lots of comments on
people
that
one.
People
like, guess what? When you turn water and put hot heat in it and it boils, that's called gas.
It's called pressure cooking or something. Yeah.
It was like, that's not what this is talking about.
Well, I actually found that you don't quite need 800 Celsius. It looks like 375 according to Chem LibreText book. And then 217 atmospheric pressure. But it's also not like you have to get exactly this temperature and pressure. It's like if you have this much pressure, that would be the temperature you need. But if you increase the pressure, you probably need... It doesn't have to get as hot to have the same effect and vice versa. So the temperature and pressure isn't going to be exact. It's like you need the combination of the two to get to the supercritical point of water. So our comment section on YouTube is wild. And on TikTok, when we did the one about what does old people smell? Comments went off.
It's funny because it just seems like to me, I mean, the old people smell one, I could see why that one took off in a different way. But several times I'm like, why did this short or this TikTok or this video get more comments and especially like weirder ones? It just seems completely random sometimes. It's like, where did you come from?
My favorite comment that I've ever gotten is the one that told me to go back to school.
Yeah.
I was like, I actually did several times.
You're like, I'm done. Okay. And now I'm back teaching. Here's a question that maybe is for another time. I don't know. But with the supercritical water thing, like, what's the chamber like where this is happening? And can we see what it looks like? Is it look no different to our naked eyes? Like, is it just like water?
Those are good questions. I actually don't know. I assume the pressure would be, or the chamber would be like, some kind of strongly reinforced metal, something that could withstand that amount of pressure and not literally explode.
Yeah.
But I actually haven't seen that type of research be done. I just know that it can.
I was thinking, like, discovering this, and maybe it's the kind of thing where someone could discover it in theory first and then prove it later, or like actually do it. But like, so if someone put forth that, hey, I think at this temperature and this pressure, water would become supercritical. What's the way that they know it became supercritical? You know what I mean? If you can't
that's a good question.
See it and it's trapped in a thing, other than the fact that like it's well above its boiling point, but it's still liquid because of the pressure we put on it. Like, I just would kind of wonder, like, how do we know it's supercritical?
Let me look into that and see what I can find.
Also, it'd be really cool. This is just like the sci-fi person to me. If it like looked different.
I think it does.
Like looked like more critical.
I think it does. It does look. It does look different. I think. I
or
remember
just like
seeing
super.
liquid oxygen, which I believe is magnetic.
Whoa.
And I think it's liquid oxygen, but like seeing basically they had turned it into a liquid and it was running through a stream of magnets and like a stream, and they had like magnets on either side of like the flowing and it moving with the magnets, and that being really cool.
Man.
So, yeah.
That's crazy. Next one, ready?
Ready.
This is from Stillpoint on YouTube. Regarding things to use your pH strips for from the poinsettias on, tea, coffee, soda, tap water, filtered water, fruit juice, rice water, all kinds of things, and then see if the color is different shades of pink or blue-gray. I wish my daughter was younger, but now she's taking chemistry at UCSC. Good stuff.
Okay, that was so fun.
Yeah.
Those are all great ideas for things to test it on. And also, just because your daughter's in college doesn't mean she won't think it's fun. I had so much fun with the poinsettia pH paper that I made. But this did remind me of a fun fact I wanted to share that I forgot to on the poinsettia episode, which is there are studies underway to try to use like the anthocyanins from poinsettias and other things that will change color when food has they'll change color when the environment, the acidity has changed. It can be potentially an indicator to determine if food has gone bad or not. So then we don't have to worry as much about the like sell by dates, which are only estimates, or the use by dates, and it could tell us if the food is actually bad or not. Like built in little pH indicators that could tell us. And I thought that was really, really cool.
That is very, very, very cool. Wow.
So that's a little bit of chemistry, just some fun chemistry questions that have built up over the holiday for us.
Those are good ones, man.
Yeah, those are good ones.
Cool. Well, thanks for all the questions that y'all sent in. If you have a question, thought, idea, something, please send it to us on our website at chemforyourlife.com. That's chemforyourlife.com to share your thoughts, ideas, questions with us. Some may be a full episode. Some may end up in an Ask a Chemist. If you got a correction or you think something is different or whatever wrong that we said, send those too. We'll take it all. And if you can, please send them on our website. That makes it much easier for us to find them. But we've clearly taken them for everywhere we get them. If we find them, if we can see them. If you'd like to help us keep our show going and can contribute to cover the cost of making it, you can join our super cool Chem community of patrons on patreon.com/chemforyourlife. That's patreon.com/chemforyourlife. You get perks, ad-free feed of the show, ways of us saying thank you for supporting the show, making it possible to exist, and keeping it free for everybody else. So even if you can't join our super cool community, thank those who do because they keep the show going and free for everybody. But we would love to have you join that community. We get to know you better. We get to thank you in some cool ways and get to interact with you, which is very fun for us. And hopefully fun for you too. If you are not able to do that, though, you can still help us by subscribing on your favorite podcast app, rating, writing a review on Apple Podcasts or Spotify, and subscribing on YouTube and leaving a comment over there somewhere to tell us you found us and say hello. That helps us to share chemistry with even more people, help more people to stumble across the show and have the chemistry of their everyday life explained to them.
And this podcast episode was created by me and Jam and all of you for writing in your questions. So thank you. And it was made possible by the community that Jam has already talked about. And we're so, so thankful that our community is willing to support us. And we want to shout them out by name. So we'd like to thank Chris and Claire S., Hunter R., Katrina B., Lyn S., Scott B., Stephen B., Timothy P., Brian K., Chelsea M., Dorien V., Elizabeth P., Heather R., John T., Jessie R., Letila, Rachel R., Autoclave, Avishai B., Chelsea B., Ciara L., Cullyn R., Emerson W., Erica B., Jacob T., Jeannette N, Julie S, Kristina G, Sarah M, Suzanne P, and Venus R. Thank you all so much for making Chemistry for Your Life happen. We appreciate you so, so much.
This is rare, but we actually have a couple of resources, references from this episode. If you'd like to check those out and look more into them, you can check them in our show notes or in the description of the video on YouTube.
And that's it. Yay, Chemistry!
Yay, Chemistry!